Okay, here we go with sheet 10. Now, question 1's a bit of a monster. There's 4 parts to it. It's probably half the homework in just that one question. So let's break it up into wee bits and do one part at a time. So question A is asking you to find the midpoint of AB. So what's the coordinates of this point here? Okay, now you should be able to do that using the midpoint formula. Halfway between 0, 7 and 4, 5. Midpoint formula, remember, is where you take each of the x numbers, 0 and 4, add them in half, and then take the y numbers, add them in half. And then that's going to give you the coordinates of point D. Not too bad, good start. For part B, right, we're told that E divides AC in the ratio 1 to 2. So we can use our little ratio formula, divides AC in the ratio 1 to 2. So what is the coordinates of A? 4, 5. What's the coordinates of C? 2, negative 2. We know the ratio is 1 to 2. So we can, let me make that a wee bit smaller so I've got space to write. We can do our cross multiplying method. So we're going to do 2 times 4, add on 1 times 2, and then divide by the 2 added to the 1, or the 1 added to the 2. In other words, divide by 3. That gives us the x coordinate, and then do the same thing for the y coordinate. Okay, the 2 down here times 5, the 1 here times the negative 2 to get the y coordinate, and then that'll tell you what the overall coordinates for point F is here. Okay, so we've got these 2 points. Next thing we're going to do is part C. Now part C says find the coordinates of F where the BC and DE intersect. So remember, this was D and this was E. I think I said F earlier, but it's E. Okay, so we need to find where the line BC, so I will need to extend BC a wee bit longer up here, and DE, this line up here, where they intersect. So I'm looking for this point up here, which is point F. So the first thing I'm going to do is I'm going to work out what BC is. To work out the straight line, I need to work out the gradient first of all. So I need to work out the gradient of BC. So you know what point B is, it's 0, 7. So that's 7 take away. And then do the same for the x coordinate, 0 take away. That's going to give you the, I'm sorry, I'm hesitating because I've just realised, Mr. West, you idiot, that I've written that the wrong way round. It should be negative 2, 2, shouldn't it? Okay, so 7 take away 2 over 0 take away negative 2, that gives you 5 over 2 for the gradient. We can use the point B or C, and y minus b equals mx minus a. So that's how you work out the equation BC. What we have to work out is the equation of DE. So let me put D and E back in. Okay. If you've drawn a diagram like mine, you'll probably find, just by looking, that it's a vertical line. Okay. When you try and work out the gradient of DE, you're going to get a fraction with a 0 on the bottom. That means the line is undefined. If the line is undefined, then that means, sorry, if the gradient is undefined, that means the equation of the line is just x equals. And it should be x equals whatever the x coordinate is for each of these 2 points. These 2 x coordinates here and here, they should be the same. That'll tell you what x equals. And once you've got those 2 points, the next thing you need to do is you need to do simultaneous equations. Okay, so let's make that a wee bit smaller, so that way I can do a wee bit of writing. Okay, so your equation of BC, let's just say that it comes out to be, so this is to find f, is, let's just say it comes out to be 2y minus 5x equals 14. And let's just say your equation of DE comes out to be x equals 2. So we need to do simultaneous equations on them. You might be wondering how we do simultaneous equations on them. Well, if we already know what x is, simply substituting it in here will tell you what y is, and then lo and behold, that's just your answer. We now reach the last bit of the question. Told you it was a bit of a monster. And it says find the ratio in which D divides EF. So let me take the picture and draw on a few extra things that we found. We know this point here is D. We know this point here is E. And we found that F is up here someplace. So I need to work out the ratio in which this little line here and this little line here make with each other. How am I going to do that? Well, the x coordinates for every single one of these points is the same. 2, 2, 2. We know that the y coordinate for f is, well, you've worked that out. You know what the y coordinate of this one is, you've worked it out. You know what the y coordinate of this one is, worked it out. Okay, once you know the y coordinates, it's just a case of getting this distance. In other words, how much is there between these y coordinates and this distance, how much between these y coordinates, and that is the ratio. So this isn't the answer, by the way, but let's say that first distance was 4, and let's say that second distance was 10, then the ratio would be 4 to 10, which would simplify to 2 to 5. Please don't write that down, it's not the answer, I'm just giving a wee example. Okay, 2, which will be a wee bit easier for us. Calculate f of g of x, so that's just a case of putting that formula in there. But it really is as simple as that. For the second part of the question, we need to work out the inverse function. Remember, your answer from the first part, whatever it is, rewrite that as y equals, and then change the subject to x equals. That's how you find an inverse. And then the last part of the question says you have to do f of g of h of x. So we're putting the h into the g and then that into the f. So we're putting x squared in here and then we're putting all of that in here. Okay, so we're just doing it twice basically. Question 3, tan a equals 2. So, little triangle, there's your A, tan, opposite over adjacent, 2 over 1. A wee bit of Pythagoras, I'll tell you that side. Tan B is 3, so again another triangle, B this time, tan B, 3 over 1. A wee bit of Pythagoras, I'll tell you that side. Then we're going to use these triangles to work out what cos B minus A is. And we know the formula for cos B minus A is cos B cos A plus sin B sin A. So get your answers from the question for cos B cos A sin B sin A from the little triangles, and then add up the fractions, just like we've been doing in class. Question 4, straight lines and circles, where do they intersect? Well, we need to substitute this little formula here in there for y and in there for y. So we get x squared plus 3x plus 2 squared plus 4x minus 6 lots of 3x plus 2 minus 28 equals 0. So you need to tidy all of that up, and if you tidy it all up, you'll get down to a situation where you've got so many x squareds, so many x's, and a number equals 0. Okay, I'm not going to tell you what these so manys are, you can work them out. Once you get to that stage there, we can factorise to get a couple of brackets. That's going to tell you the x numbers, and then substituting these x numbers back in here is going to tell you the y points, so that you can get the two coordinates where the straight line intersects. Question 5, one of these logs that we need to simplify. I'm not going to do it all, I'll do the first bit for you, you can do the rest, it's very similar to this. Okay, the first thing is the third goes up here as a power, so that becomes log to the base 10 of 6 to the 4 to the power 1/3. We should know that 6 to 4 to the power 1/3 means the cube root, and we should know that the cube root of 6 to 4 is indeed 4. So if you do the same for the middle part, you do the same for the last part. Because they're all adds this week, then all we need to do is take this number, this number, this number, and multiply them together. Because remember, when you're adding logs, you do multiplies. And it should hopefully simplify to something nice and easy. Question 6, we've got the formula m of t equals m naught e to the kt. Now remember, when it says half-life, then that means when does this little part of the formula equal a half? When does e to the kt equal 0.5? Okay, you don't need to worry about the mt, you don't need to worry about the m0, right? We just need to know when this part here is a half. What else does the question tell us? The question also tells us that the half-life happens when t is 60. So I'm going to put 60 in my formula, so e to the 60k equals 0.5. How do you get rid of the e to the power? In other words, what's the opposite of e to the power? The opposite of e to the power is ln. So ln 0.5, then you can work out what k is. Part of the question, oh look, there's what e is. Hope you got that. For the second part of the question, how long will it take for the isotope to decay by 95%? So if you started with 100 of the isotope, how long would it take before there's only 5 left? So I can put 5 and 100 in there, e to the minus 0.012t. Okay, rewrite it as 100, e to the negative 0.012t equals 5. Take the 100 over, then you're left with the exact same situation as you had before. What's the opposite of e to the power? Log. So you just do what I did before for the next part of the question. Last question, possibly the easiest one, 2 vectors. Now please note I've taken them from the IJK form and I've rewritten them as a column vector, 1, negative 2, 1, and so on. Okay, part A says that they're perpendicular. So what is the condition for perpendicular vectors? Condition is that A dot B has to equal 0. So we're going to do 1 times negative 2, and for some reason guys you keep forgetting you've got to add negative 2 times negative 3, and then add 1 times c, and that's got to equal 0. So solve that and you'll be able to work out what 0 is. And then the first question was a monster, the last question is really easy. Okay, it doesn't look it, but it is. We know that pi radians is equal to 180 degrees. If the angle is 180 degrees, if you've got one vector which goes like that, then 180 degrees angle would mean the other vector goes like that. Okay, in other words, they're in opposite directions. So what does that mean? It means the signs of these numbers have to be the opposite. So it's kind of obvious, if this one here is -1, what the value of C is. Right, okay. That's it.